Alright, ladies and gentlemen, we are talking about understanding the terms atoms, elements, compounds, and mixtures. You have some Cornell notes that look like this. Let's go ahead and get started. We want to make sure that we're focused on our essential question here of how do you determine the number of atoms of an element that are present in a chemical formula? So I know in math you guys learned about the distributive property. So for example, if you have for it's not letting me write C plus 9. Okay, in math you would do 4 times C and then 4 times 9 and add those together. So we're going to do something a little similar when we're dealing with this topic. Alright, your first main question, so over to the left it says what is an atom? So this is number 1. Okay, the atom is the basic component of all matter. We were already drawing atoms in the first couple weeks here, so this is a picture of an atom. Okay, so an example, because it asks you to list an example underneath, you can write an atom of beryllium. And we know this is beryllium because I have 4 electrons in my electron cloud. I have more rings than I need, but I have 4 electrons. My second question or main idea says, what is an element? Well, an element is a substance consisting of a single type of atom, and it cannot be broken down into different kinds of matter. So you know the periodic table of elements has all different kinds of elements from helium to hydrogen. Okay, you cannot break those down into anything else. Helium is always helium. It doesn't become anything different. You cannot split the atoms, nothing. It is what it is. The third essential question says to define mixture. So that's this here. Okay, a mixture is a combination of elements. Okay, so it's a substance consisting of 2 or more substances that are mixed together. Mixtures can usually be separated by mechanical means. So 2 or more substances mixed together in such a way that remains unchanged. So a common example that you probably remember from early science is a salad. I could take this salad right here, I could take out these mushrooms, I could take out the tomatoes, I could take out the black olives. I might leave those in because I like them, but I can separate those. Another food example, because I like food, I can do trail mix. Okay, like there's different kinds of nuts inside there. Sometimes people put dried fruit, things like that. I can separate a mixture. Another common example you might remember is oil and water. Okay, remember, you probably hear people say oil and water don't mix. That's because they don't. Okay, their densities are a little different, so they don't combine well together. So they can't be separated. Alright, next we have compounds. Number 4, it says define compounds. It is a substance formed of 2 or more atoms or elements. Okay, the elements lose their individual chemical properties and the compound has new properties. So you all have heard of H2O. And you probably know that there are 2 atoms of hydrogen and 1 of oxygen. Okay, so this is a compound. Alright, they're no longer just hydrogen by themselves and oxygen by themselves. They are now water. They've lost the identity of just being elements. They're being combined to become something new. Make sure you write that down as your example in your notes. Now we are going to define molecules. Molecules are compounds of 2 or more atoms. So this is an example of a molecule of water. Okay, and we're actually going to create little examples of molecules in class so you can see that. So this is one molecule of water. This represents hydrogen, the yellow, and then the red is your oxygen. Okay, what if I wanted 2 molecules of H2O? Well, I would just recreate them just how you see it, and they will be bonded. Okay, because I didn't draw this model right next to this one, I have two separate molecules of water. Okay, so each of these is an individual molecule of water. Alright, now we're on number 6, which is what are formulas. Formulas are numbers and types of atoms in a molecule. The formula which identifies the atoms and the number of each kind in the molecules of a compound. So this is an example of a formula. Now this one is actually kind of poorly written. So what I'm going to do is I'm going to rewrite it so you have a better example for your example in your notes. So example should be C, capital C. Remember, if it's capitalized, leave it that way. This 6 should be a subscript. Then you should have a capital H, and then a subscript 12, and a capital O, and a subscript 6. Okay, and I started using the words that you will see in our word question main idea number 7. Okay, these are subscripts. It tells me how many I have. So I have 6 carbons. I have 12 hydrogens. I have 6 oxygens. So just like in the formula, H2O, I have 2 hydrogen. And you don't see a subscript here, but we want to conclude, because I see that element symbol there, that there is at least one. So that's how I know I have 2 hydrogen and 1 oxygen. Alright, we are on to the last one, number 7, my subscripts. Okay, you're going to have to fill in the entire definition there. A subscript is a small number to show the number of atoms of each element, like I just showed you on the previous slide. So if I look at these examples, remember, there's the capital. Each capital will separate each element. Okay, so I have carbon. I don't see a small number next to it, so I know that's 1. And then oxygen has a small 2 next to it, so I know there's 2. So I have 3 total atoms there, from 1 from carbon and 2 from oxygen. Here in this CH4, I have 1 carbon and I have 4 hydrogen. In this example here, I have 6 carbon, I have 12 hydrogen, and 6 oxygen. Alright, the very last definition that you need to write down is for your coefficients. It is a large number that tells you the number of molecules in a chemical formula. It also can be added to balance an equation. We'll get to equations here and probably next week. So remember when I had the example of this, I had a picture of H2O and I told you I didn't combine them. This by itself is one molecule. This by itself is another molecule. They're not touching each other. So I have 2 molecules of H2O. Okay? Now very quickly, let me show you what we're going to get into. We would box this, and I'm going to make sure with that distributive property that I have the correct amount of each element. So if I do 2 times hydrogen, I have 4, and that's 1, 2, 3, 4 hydrogen atoms, and then I'm going to do 2 times my 1 oxygen. 2 times 1 is 2, and I have 2 oxygens. So ladies and gentlemen, that's it. This is the end of your notes. Make sure you had everything filled in and that you've answered all your Edpuzzle questions, and be ready for class discussion.